Hi guys, welcome to your Chapter 5 video part 1. This is actually the second recording of this. And before I mention anything about that, let me first apologize for getting this out so late. For those who are very dedicated and watch videos in advance, my apologies rather, excuse me. Let me do my best to get out the Chapter 5 part 2 video tomorrow at the latest, so you guys can have that plenty in advance. I'll try to make that up to you by being as diligent as I can to get these out. Just a busy time right now. Alright, so Chapter 4, we started to talk about descriptions and displays of quantitative data. What we didn't do too much in Chapter 4 is get at how we can summarize these distributions of quantitative data in a numerical way. We spent a lot of time talking about shape of a histogram, skewedness, outliers, gaps, symmetry, uniformity, modality, those sorts of things. And with center and spread, and a lot of you guys asked, great questions, how do we report this? And we just kind of left it at, well, for spread, report the range, the difference between high and low, or excuse me, high and low, and for the center, you just report the median. Well, in Chapter 5, we're going to get into how to report the center and spread in a more constructive, maybe more descriptive way. And let's first start with the first two slides here, doing a little bit of a recap. We've got three distributions shown. When these notes were first designed, I had not yet talked to the kids about where the median would fall in the histogram. So, okay, we know that the median, if you've got, let's look at 1, 2, 3, 4, 5, 6 data values lined up in ascending order, we know that the median value is going to be in the middle, so to speak, so that 50% of the data falls to either side. In this particular case, you could say, okay, well, the median has to be between 3 and 4, and to get that, you would take the average of 3 and 4, divide through by 2, so you get 3.5 for a median. So the median cuts the data, so you got 50% of the distribution to either side, and it falls in the center. Okay, well, in ascending order. The reason that we can cut these histograms vertically to find the median is that on the horizontal axis of each of these three histograms, you've already got the quantitative data set up in ascending order. For this first one, top blue, we've got from 1 to 25, and going in numerical order between 1 and 25. Same with the 40 to 140. Same with, I can't read the bottom left. So the data is already set up in ascending order, and we know that these bins, because of the area principle, we know that these bins denote the amount of data falling in that range of 1 to 5 or 6 to 10 or 11 to 15. So it's simply a matter of doing sort of one of those vertical slices that I've done with the dotted lines. We might be able to say that it would be about here that we would have the cut for 50% of the data, and that would be our median. Alright, second thing here, range. Okay, we've talked a little bit about how to find the range for a histogram. We've not necessarily seen that for a set of data. Hopefully this is going to be intuitive enough. I would be surprised if this is a system shock to anyone. Okay, so the range is just a simple difference between high and low. For your data set, 45.8 minus a negative 17.5, which would be equal to, let's see, add 20, 60.8, subtract 2.5, you get 63.3. So there's the range of our data, which is simply what the span from high to low of the data is. For a histogram, you can usually find that at least approximately by comparing the highest cutoff point for your largest bin, or not your largest bin, but the bin that has the biggest data values in it, and the lowest cutoff point for the bin that has the smallest data values in it, and that would be your range. Check out this histogram here. Hopefully the book will not make these sorts of mistakes, but it has presented histograms wrong in Chapter 4. I think I was talking to Allie Howard about a histogram that she had seen, looked a little off. she saw gaps, I believe, in between the bins. It'll happen sometimes. One other thing on this histogram that's a little bit off is that the hash marks on the horizontal axis are not where the bins are separated as they really should be. It's somewhere, you've got these weird hash marks in the very middle of the bins. Now what exactly that's supposed to mean, I don't know. So just be careful. Make sure that, let's say for instance here, on this histogram you were to report the range as part of the spread. Well, you could say that you believe that the range would be equal to this 230 minus 160, which is 70, which is approximately, let's see, I should really use the approximate equal sign right here. The range is approximately equal to 230 minus 160, which is 70, because the histogram's been a little bit messed up, and that's the best we can do. Alright, now with the new. Quartile 1 and quartile 3. Today the focus is on the 5-number summary. This includes the min of the data set that you've got to work with, the max of the data set that you've got to work with, the median, which you've seen before, and then the two new are quartile 1 and quartile 3, which will give you the interquartile range, which we will see shortly. Quartile 1 and quartile 3 are built very similarly to the median, so I think they will be relatively intuitive for you once you get started here. Let's check out this data set, which has 9 data values in it. The way that if you were to construct or to find quartile 1 and quartile 3 by hand, you would do that is you would first say, okay, let's make note of where the median is. That has now divided my data set into 2 equal halves, and the quartile 1 for the lower set is basically the median of that bottom 50% of the data. So quartile 1 here would be equal to the average of negative 17.5 and 2.8, which would come out to be, let's see, subtract, did I write this down? I did, good, okay. Just to double check, negative 7.35 is my quartile 1. Okay, similarly for the upper half of the data, quartile 3 is equal to the average of 25.3 and 45.8, which would come out to be, did I write this down? Awesome, 35.65. Okay, so let's make note of these right here, that for this look at the data set in red, we had quartile 1 at negative 7.35, and we had quartile 3 at 35.65. Okay, so what these quartiles are doing is the median is the cutoff point for which we have approximately, not necessarily exactly, but approximately 50% of the data below that point. Quartile 1 is the cutoff point for which we have approximately 25% of the data values below that point. Quartile 3, we have approximately 75% of the data below that point. And they are, just like the median, they are measures of where the data is tending to be, and they are very useful relative to each other. We don't, thankfully, have to find the median, the quartile 1, and the quartile 3 by hand. If we did, that would take a bunch of time. We would be able to make way less conclusions statistically in this class if we had to do all that by hand. Your calculator will do that for you, so I'm not going to belabor the issue too much here by doing more of these by hand, because at the end of the notes I'll show you how to do that on your calculator. What else? There was another piece I was going to say there. Oh yeah, the other piece is that to find quartile 1, the median, and quartile 3, there are like 6+ different methods of doing that, so there's not even necessarily any agreement as to how this should be done. But that's okay. It's okay that quartile 1 and quartile 3 don't have a set procedure to find them, because they are most useful. These numerical descriptions of the data right here are most useful when the data set's really big. That is to say, we have a lot of data values. When you have a lot of data values, the differences between quartile 1 and quartile 3, or the median and these 6 different ways to compute them will be negligible, because you just need some sort of numerical breakdown of what the data is tending to do. So don't fret over the differences, it won't matter. Okay, note that like the median, quartile 1 and quartile 3 don't care about individual data values. Our highest and lowest data values could be huge and super tiny respectively, but our quartile 1 and quartile 3 values wouldn't be influenced. That is to say, if we had a very low outlier here of, instead of negative 20 of the lowest data value, we had negative 1,000, and similarly for the topmost data value we had, let's say, 5,000 instead of 50, the computation for quartile 1 and quartile 3 along with the median would be no different. We would say that statistically these summaries, these statistics of the data, that quartile 1, quartile 3, and the median, are resistant to outliers. They are resistant to skewedness as well. They are reporting where the data tends to be, but they don't care about extremes. Okay, the interquartile range is built from the quartiles 1 and 3. It's a measure of how spread out the middle 50% of the data is. Because note, if quartile 3 is the point at which 75% of the data is less than that point, and quartile 1 is the point at which 25% of the data is less than that point, if we take the difference between these two, 35.65 and negative 7.35, which gives us, did I write that down? Is that 43? C8. Yep, I think so. Quartile, the interquartile range would be 43. What that means is that the middle 50% of the data from this guy to this guy exists in a range of 43 units. And it's one way that we can describe where the distribution is centrally, where the data tends to be in the middle. Alright, so let's go ahead and write out the 5-number summary here real quick for the same data set that we've been looking at. We have, for a min, because the data is already in ascending order, that would be negative 17.5, a max of 45.8, a median here I think we found before of 13.9. Same data set as last slide, so I'm going to ignore doing any computations here. Quartile 1 is at 2.8, and quartile 3 we said was 25.5. Let me check those real quick. What did I do here? Oh, okay. The data set is not quite the same. Negative 20 and 50 have been removed from this data set. Okay, so good to make note of that. Does the min change from what I had written down originally? No. Max is good. Median is good. Quartile 1 now, if the median's right here, quartile 1 would be at 2.8. And quartile 3 would be at 25.3. Okay, good there. And that's the 5-number summary. From that, you can get the IQR with the, yikes, what is that? With the difference between these two right here. Again, that is quartile 3 minus quartile 1. The measure of the range of the middle 50% of the data. When we want to describe a quantitative distribution, we care to report the shape, center, and spread of the data. Which of these does the 5-number summary provide for us? Well, by looking at the data values like this, we obviously get nothing about the shape of the data. And if you have a really big data table like we looked at the beginning of chapter 2 that has a lot of these such numbers built up maybe dozens or hundreds of times, it's really hard to, even if you put them in ascending order, your brain will not be able to visualize what's going on very easily, especially when you get up to the hundreds of data values at a time. So nothing about the shape is being described by the 5-number summary. The center, absolutely. We've got the center described in the same way that we have described the center from a histogram. We've got the median reported for us. And now the spread of the data, you don't need the histogram to report spread, because you're doing two things here. Not only are you getting the IQR, the middle 50% clustering, or the spread of the middle 50% of the data from the IQR, you're also getting from the min and the max, you can report the range. Okay, so the 5-number summary really gives you two reports of spread in one, range and IQR. What tools might we need to be able to report about what's left of shape, center, and spread? Well, we said that shape was left out, so you've still got to have some sort of graphical display to be able to talk about the shape. Skewedness, outliers, gaps, etc., etc. Alright, I thought that last year, simply going from talking about the 5-number summary to jumping to a new sort of display about the 5-number summary left some people hanging as to where in the histogram these 5 numbers exist. So let's go ahead and, with this histogram here real quick, you've got these descriptive statistics upper right. Don't really need to pay attention to those. Just check out the horizontal axis. I don't know what data is being measured, but it spans between 0.5 and just below 7.5. You've got the frequency on the vertical axis, so we're not looking at percentages here. Although, they've also kind of a nice job here. With these bins, we've got the count above them, as well as the relative frequency of the data in those bins. So that's kind of cool. All right, in this distribution, we've got, trying to cut this vertically as best I could earlier, I think that right about here you've got the median. I'll put an arrow to that. The median seems to be at approximately 3.8. Now why 3.8? Well, we're going for about 30% of that bin width from left to right, and the whole bin is 1 unit wide, so 30% of 1 is 0.3, so I added to the 3.5 the 0.3 to get the 3.8. Alright, quartile 1 is, so the median again is where 50% of the data is less than that point. That does not show up well, at least on my screen. Let's see if we could do this. I want the contrast with the white background. 50% of the data is less than the median, okay? The quartile 1 looked to me to be at about 2.8 right in here. So we have split the area of the distribution to the left of the median. That would be all of this right in here. The distribution to the left of the median, we split that in half to get quartile 1, which appears to be at about 2.8. Alright? And so that is where 25% of the data is less than that point. Quartile 3 looks to be at about 4.7 or so. We're running out of room here, and that's where 75% of the data is less than that point. You've got the min over here approximately at 0.5. We don't know that the minimum data value is at 0.5. We just know that's where the lowest bin cuts off, or rather begins. And then the max could be at about 7.5. So I think hopefully that makes it a little bit clearer visually as to where the 5-number summary falls in the histogram here. For some of you, I'm sure you already understood that, but that was not clear last year. Let's see if there's anything else I want to talk about here. Yes, so the IQR is as we said before, the difference between quartile 1 and quartile 3. So the difference between this guy and this guy, IQR. Difference between quartile 3 and quartile 1, we said in the past, was or is rather for this data set. We've not looked at this before. 1.9. So that is 4.7 minus 2.8. And you can kind of see based upon those vertical cuts that I made on the left and on the right of the median, we have seemed to split the distribution up so that the interquartile range is showing us the span of where the 50%, the central 50% of the data lies. All right, let's go forward now to the box plot. The box plot is just as common to use as a histogram would be to report a quantitative distribution, and it'll be really important. The box plot's particularly important if you're trying to compare two distributions. So it could be, let's say you want to compare distribution of heights in my first statistics class to in the fourth. You could set up parallel box plots, and I'll show you how to do that next slide. And they're going to provide you a quick and dirty summary of how the students' heights might differ. All right, so with this same data set we've been looking at past few slides, I think it's helpful to just look at the same, keep things consistent. We got the min of negative 17.5, max of 45.8, median of 13.9, quartile 1 is 2.8, quartile 3 is 25.5. Alright, so how does the box plot work? Well, first thing you do is you report the median with a little hash mark here, and that is going to be at 13.9. So these hash marks are separated, the span from 0 to 20. We've got 4 hash marks to go from the 0 to the 20th. So we're separated by 5s. 13.9 is going to be just past halfway between 10 and 15. So right about here. That represents the median. You've got your first little hash mark to represent the median. We're going to set up this box plot parallel to the horizontal axis representing our quantitative data, or where our quantitative data might be. Quartile 1 we set up next. That's at 2.8. So that's going to be just over halfway between 0 and 5. Quartile 3 is at 25.5. So basically at 25. Okay, now we're going to connect these with lines parallel to the axis we've set up. So that shows us right here, you've got quartile 1, median, quartile 3. Remember that the IQR is the difference between that quartile 3 and quartile 1, so you can see where the middle 50% of the data lies. And from this, now we do it's called a box and whisker plot for a reason. We've got the box, we don't really have the whiskers yet. We now need to set up fences that will define where the outliers are and where the whiskers are. To set up a fence for a box and whisker plot, you first need to know the IQR. And the IQR here is equal to, let's see, I didn't write that down. So 25.5 minus 3, essentially 22.5. Add 0.2 to that, 22.7. Okay, so the IQR is about 22.7, approximately 23. Your fences are 1.5 times the distance from quartile 3 and quartile 1. So your topmost fence is going to be 1.5 times this guy right here, which, if that's approximately 23, then that would take it up to about 34.5 beyond where quartile 3 is. Okay, so fences are, let's see how to write this. They are 1.5 times IQR from Q1 and Q3. Okay, so 1.5 times that 22.7, approximately 23, we said was 34.5. Add that 34.5 to quartile 3 and you get 60. Okay, so 40, 50 right over here. There's your topmost fence. Now that 1.5 times the IQR, again, we said was 34.5. Subtract 34.5, excuse me, from quartile 1, and you get about negative 31, I believe. So bottommost fence would be right over here. Does that visually look good? Yeah. Okay. So the fence is the distance between quartile 1 and that bottommost fence should be should appear to be about 1.5 times as wide as the entire interquartile range. Similarly, distance from quartile 3 to the topmost fence should be about 1.5 times that width between quartile 1 and quartile 3. Alright, now where do the whiskers go? Well, now we look at the data. We've got a minimum data value of negative 17.5. That is within quartile 1 and the lowest fence. So we're going to make that into a whisker here. Alright, it's halfway between this negative 15 to the right of that negative 20 hash mark and negative 20. So there's your bottom whisker. Now for the top whisker, we see that the max of the data values is 45.8, just barely past this 45 right over here. There's your topmost whisker. So the way that these fences work is that the lowest data value between quartile 1 and that bottommost fence right here becomes your bottom whisker. Okay? The highest data value between quartile 3 and this fence over here becomes your highest whisker. If there are any data below this bottom fence that I first put an arrow to, you would report that with a little tiny box like this, or a circle, or if you want an asterisk. It doesn't really matter. What that does is those fences define for us where the outliers exist. So anything to the left of this bottommost fence would be an outlier for this data set. Anything to the right of this topmost fence would be an outlier as well. Okay, we don't have any data that goes beyond our fences, but if we did, we would, again, denote it with stars, boxes, asterisks, whatever little shape you want to. That doesn't really matter. So the box and whisker plot has done the following for us. It has shown us where the interquartile range, where the middle 50% of the data tends to be. It has given us the marks for where the cutoff, at where 25% of the data is less than our quartile 1, 50% less than our median, and 75% less than our quartile 3. And it's also, with these whiskers, given us some sense of where the min and the max are. If we don't have any outliers, those whiskers are truly the min and the max. If we do have outliers here, those whiskers represent where the min and the max might be if the data is all doing about the same thing. Now that's confusing. Basically, data values, those asterisks, those stars outside the fences, if we had data like that, there might be some reason why that's going on. If this box plot represented the heights of students in a stats class, and ignore these numbers, obviously you can't have a height of negative 20, it might be very strange for us to have some student so tall that they exist that far from the rest of the data set. They're super far from the median, super far from the quartile 3 and quartile 1. That's kind of an extreme case. Similarly, on this low end, if you're looking at heights of students, you had someone well beyond that lower fence. There might be some reason for that. Maybe there's a genetic disorder causing that super low height. Who knows? But the box and whisker plot is trying to, within the fences, tell us what the data normally does. Outside the fences are our extreme cases. Alright, so a lot that was said there. Hopefully that made some sense. Note that the following things are happening in our box plot. The box is showing the middle half of the data. We said that. Location of the median in the box may denote skewedness. Okay, we did not say that. So here in this box plot that we have above, The median looks to be about halfway between quartile 1 and quartile 3. If, on the other hand, the median was right over here, let's say that we didn't have this guy at all and the median was really close to quartile 1, that would mean that about 25%, the bottom 25% of the data would be in this range. The next 25% of the data would be in that next circled range. And then, to the right of the median, we would have this big span where the topmost 50% of the data lies. And it's spread out across a bigger width of the box plot than the bottom 50% is, suggesting that if this data were presented in a histogram, this data might be skewed right. Okay, so you're looking, so you can make a visual comparison, see where that median is. If you've got a big distance between the median to quartile 3, your data might be skewed right. In short, if you've got, let's see if I can back this up over here. If instead of the median being right here, we had a median right over here, now you've got a big span to quartile 1, it might suggest that our data would be skewed left. Okay, that's the second thing. Boxplot rocks at finding outliers and making those visually clear. Yeah, we already talked about that. Alright, third thing here. Rather than going through all the humdrum in the first paragraph, which all it's saying there is basically, hey, the boxplot can be used to compare distributions. Let's go ahead and show you what comparative box plots look like. Okay, so I'm going to go through this really quickly. You've got the 5-number summary plus the interquartile range presented to you for two different mugs types, a SIG mug type and a Starbucks mug type. And basically someone has gone through and many times, 8 different times per mug, they have measured the temperature drop before and after this 30-minute mark. Okay, so you're pouring hot coffee in, and then 30 minutes later checking to see what the temperature is at. All right, so for the SIG cup, the median's at 14.25, so just below 15, probably not that close, 15, right about there. We've got quartile 1 at 11.50. 30% beyond the 10, right about there. Quartile 3 is at 21.75. Let's see, is this set up so far? Yeah, I think it looks good. Okay, so there's your box. Quartile 1, median, quartile 3. Your whiskers, or excuse me, not your whiskers, your fences are going to be 1.5 times below. So this width here of the stuff in red, if you want to do quick whiskers, you can. I'm going to do that for the sake of the video here. So you'd have whiskers like over here, below 0, and then to the right of 25, 30, 35, like way over here. So you've got whiskers that are way out there. Then, or excuse me, fences that are way out there. I keep calling them whiskers. Then your whiskers min is at 9, so right about here. Your max is at 24.50, right about here. There are your SIG. There's the box plot for the SIG cooling times. Alright, now let's look at Starbucks, and let's do like a green for this. We had median at 8.50, which is just below the min for the other one. We've got a quartile 1 at 6.50, so right about there. Quartile 3, 14.25, about there. Okay, there's your first box. The fences, again, really far from that. The min and the max are going to fit within those fences, so I'm not going to bother to draw them. Min is at 6, like right here. The max is at 17.50, halfway between 15 and 20. And there you go. So that's Starbucks. And yeah, that looks good. Okay. All right. So With these two box plots, you could compare shape, center, and spread here. We could say that based upon the shape that we see, it certainly looks as if the distribution of cooling times is skewed slightly right for both the SIG cooling times for these mugs and for the Starbucks cooling times for those mugs as well. It looks like we would say something about I'm losing it. So we've done shape, center. The center of the data for the SIG cups median we've got. Starbucks for the SIG cups, or Starbucks cups, the median's at 8.50, and it looks like the middle 50% of the data for these Starbucks cups is lower than it is for the SIG cups. So it certainly looks like the Starbucks cups tend to outperform the SIG cups in terms of keeping the coffee hot, right? They have, this data was collected by taking the original temperature, subtracting the temperature after 30 minutes into that, and so you've got these positive values. So lower numbers suggest that there is less cooling going on, right? If you've got a high positive value, that means then that you had a very high temperature that dropped significantly in that 30-minute window. All right, so you can compare shape, center, and spread with the box plots. We did center, spread a little bit with the interquartile range. I'm going to stop right there. If you want to talk further about shape, center, and spread with box plots, we can in class. This video is getting long enough as is. Excuse me. Let's make comparative box plots with the TI-84s. Let me show you how to do that really fast. Let me check the time here. 36. We're going to get this done quickly. Turn this guy on. File open. Initialized. Okay, what I've done, you've got two different data sets for boys and girls. I don't care about the context at this point, just want to show you how to do this. Boys are in L1, girls are in L2. You can make comparative box plots by going to second stat plot. You turn the first plot on. You choose, I don't think you'll ever have a reason in this course to choose this fifth selection of graph. Choose the fourth instead. That will show you outliers. The fifth will not show you outliers, and we want to see outliers. We want to know when we have extreme data values what might be going on there. Okay, so we've got the boys L1, X list frequency 1. The mark I'll keep at that square. Now I'll go back to stat plot because I want to do comparative box plots. This is one of the only times where we can have two plots or more going on at the same time. I'm going to turn this on as well, choose the same box and whisker plot type. L2 is the girls. I'll change the mark to something other than the square, so my outliers, what that does is that denotes the outliers. Outliers for the girls will be represented with plus signs. Outliers for the boys will be represented with the squares. Okay, and now Zoom Stat does a freaking awesome job with comparative box plots. We can trace, and that shows us the, wait, why? Oh, okay, never mind. That's going to show us the bottom whisker, so the lowest, that's actually the min of that of the data set for the boys. It's showing us L1. We knew that L1 was in the boys. The quartile 1 is what you go to next when you trace across. Oh, and it even says that, 18. The median's at 22. Quartile 3 is at 23. And the max data value in that set is 29. Okay? Now go down, just hit down, and it'll go to your next box and whisker plot. It'll give you the max, quartile 3, median, quartile 1. It just says X here because that's not the min. You've got an outlier. You've got one girl who I guess didn't jump that many lines in 30 seconds, and so she is an outlier, and that's represented with the plus sign that we chose earlier. All right, and there you